Hi, I'm Kritika and I'm going to be solving question 6 of the Endsem. So question 6 asks us to consider this y double dash plus 16y is equal to 4 into delta t minus 3 pi, given that y0 is equal to 0 and y dash 0 is equal to 0. So thing about the delta function is that it behaves like this. Infinity when t is equal to 3 pi and 0 otherwise. So I could multiply it with 4 and the result would be the same. So the first part of the question asks us to define what kind of real life phenomena is captured by the delta function if this ODE represents a mass spring system. So if this represents a mass spring system, this is the external force, that is the RT, that is applied. And since it's a delta function, it's just behaves like an impulse that acts on the mass. Like if this is your spring, this is your mass, just an impulse for a very, very short period of time, and a high amount of force is applied, and that's called an impulse. So delta behaves as an impulse to the mass spring system, and applied at the time t is equal to 3 pi by the definition of this delta function. Without solving, we're supposed to sketch the graph of the solution. So we know that there is no force being applied before t is equal to 3 pi. And at t is equal to 3 pi, for a very brief moment, force is applied. And after that, because it's a mass spring system, it will begin oscillating. And because it's oscillating, it'll be oscillating in the form of a sine or a cos curve, right? So this is like the t axis, and this is 3 pi. So after this time period, there will probably be an oscillation like this. So now we're supposed to solve the ODE and then sketch the graph of the solution. So one important thing about the delta function is that if you have suppose 0 to infinity g of a, delta t minus a, right, and a has to lie between 0 and infinity. So if a does that, the integration of the delta function by the definition of the delta function is 1. And the reason why is that the delta function, it behaves like, suppose this is a, and it behaves like there's no force acting, and then there's a serious like spike, and then 0. So by the definition of the delta function, the area under the curve at delta t minus a is equal to 1. So that implies that this and yeah, a has to lie between 0 and infinity. So the integration of this, that means, would be g of a. So why this is important is because the Laplace of a of anything, actually, that itself is an integration between 0 and infinity, and we could use those properties to solve this question rather than trying to solve it in any other way. So let's apply the Laplace to the left hand side and right hand side of this equation. So that means that the Laplace of y double dash plus 16y is equal to Laplace of 4 delta t minus 3 pi. Now we can, by the properties of Laplace, we can split it up. So this is Ly double dash plus 16. We can take 16 outside. Ly is equal to 4 L delta t minus 3 pi. Now there is a property, or this formula, that Ly double dash is equal to S square Ly minus sy0 minus y dash 0. And over here we've been given that y0 and y dash 0 are 0. so we can just ignore that. So ly double dash is s square ly. So I can take the ly common, is equal to s square plus 16 into 4 into Laplace of this. Now the Laplace of anything is equal to 0 to infinity e power minus st into that function itself. This is t minus 3 pi, and by this above property it will just be, and because 3 pi lies between 0 and infinity, that's why we can use this property. So by this above property, this will just be 4 into e power minus 3 pi s. So you can take this over here. And so to find y, we'll have to do Laplace inverse of 4 e power minus 3 pi s divided by s square plus 16. And over here we're going to have to use the second shifting theorem, because there's no really straightforward way to just find the Laplace inverse of this. What we can find is the Laplace inverse of 4 by s square plus 16. So we know already that the Laplace inverse of anything in the form of omega divided by s square plus omega square is equal to sine omega t. So omega over here is 4, omega square is 16, and this is just s. So that means that the Laplace inverse of 4 divided by s square plus 16 is equal to sine 4t. Now let's talk about the second shifting theorem. So the second shifting theorem states that if L of f of t is equal to f of s, then L f tilde t is equal to e power minus as fs, where f tilde is equal to f of t minus a ut minus a, and u is a switch which is applied after t is equal to a. So ut minus a, the property of ut minus a is that it's 0 before a and 1 after a, so that's why I'm calling it a switch. So so applying this to our previous to what this L inverse of 4 e power minus 3 pi s. So since we know that L inverse 4 divided by s square plus 16 is equal to sine 4t, hence L inverse of 4 s square plus 16 into e power minus 3 pi s is equal to sine, and this acts as our a, so sine 4t minus 3 pi into ut minus 3 pi, and this corresponds with the impulse being applied at the time t is equal to 3 pi and the oscillation starting after that. So this is equal to sine 4t minus 12 pi into ut minus 3 pi is equal to y, and 4t minus 12, sine 4t minus 12 pi is just sine 4t. So we've got that y is equal to sine 4t into ut minus 3 pi. So now the graph for ut minus 3 pi is 0 before 3 pi and 1 after 3 pi. So the graph for y, and that's a graph for standard graph for sine 4t. Now the first thing is that it will vary between minus 1 and 1. This is minus 1, this is 1. Let me make that a little closer. This is 1. And since this is sine 4t, so width wise the magnitude will decrease by 4. So say pi, 2 pi, 3 pi, 4 pi, 5 pi. So if one complete oscillation was in this much, in this width, it'll for sine t, for sine 4t it'll decrease by 4 times. So let me go ahead and divide everything into 4 parts, because it's going to shrink by 4. And the real graph, it starts after 3 pi, but I need to know like at what turn it will be. So I'll just start with a dotted line over here. So sine 4t is going to be like this. So it starts from here, and the solid line is what the actual graph is. And so on. So this is the final solution, and we were supposed to compare the two graphs. So my initial like rough graph was this, and it corresponds exactly.